Welcome to the Osmosis Autonomous Simulation demonstration. We are Group 6 for Assignment E7, and this demonstration is for CS6310 Software Architecture Design. Before we start, let's meet our team member. My name is Xinyue Li. I'll be the one giving the demonstration for today. We also have Liang Qiu, Jiayi Jiang, and Rahike Chen. Okay, let's get started. As you can see, we're using Java for building our backend system. At the right-hand side, it is our application interface, which we're using the swing. The top menu, we have a file option, which allows user to upload scenario, export result, and access. For help, about is our team's information. The instruction will giving a user guide about these 5 buttons here. The next means manually put the next object for simulation run. Fast forward will automatically execute the current simulation to completely. Pause will hold the simulation at the current state. Stop will terminate the current simulation run. Reset will terminate at the current simulation run and set the original state to the scenario file when just uploaded. Below the bottom, we also have some information here. This per client's requested, and it will be updated once we have a scenario file ready uploaded. And below the information, we have a simulation state box. This part will be displaying the same information as well as the terminal view. And below that, we also have a mover status and the progressive bar showing the complete turn out of the maximum turn. All this information will be updated accordingly once we have a scenario file. So let's take a look when we have a scenario being uploaded. When loading the scenario, it will validate the scenario file's format as well as the file path. It can take in both a CSV and text file. In this case, we're using a demo test scenario. Let's open it up. So now you see a map being pulling up, as well as some information being updated on the application here. The next object showing AMP0 representing mover 0 will be the first one taking action. Completely turn is 0 because we hasn't started yet. Maximum turn is 150, which is per scenario setting. Size of the long is 120, which is the area of the map. It is also part of the scenario setting. Grass car so far is 5 because in this case we have 5 mover, and when mover being placed on the grass, it will remove the grass right away. So does the remaining grass, which are the size of the lawn minus the grass car so far. The simulation state is left to blank because we haven't started the system yet, and the mover status has been updated with showing the total number of the mover with its mover ID, their initial direction, their energy level. The energy level is per scenario setting. In this case, we have 120, and the right column we have the status, which will showing either mover is alive or crashed. Since we haven't started yet, the completely turn will be remain as a 0. Now let's take a look to the map. The grade of the map will be fences, and that's why you see the top and right side has all been marked with the fences picture. We also want to provide user a clearly and intuitive look, so we keep the bottom and the left side with the X and Y coordinator. For the map, we have the green representing the grass to be removed, and once it has been cutted, it will be left as a blank. We see the gopher with the grass representing gopher is currently under the square of a grass. Also, gopher can stay with the empty square as well. For the movers, their initial position will be the charging pad. That's why we see a battery as a background icon for all the movers. The top right number here representing the mover's ID number, and the arrow here representing the mover's initial direction here. These information are consistent with the mover status being shown at here. So let's now pull in mover for action. When user click next, it will showing what object, what kind of action it will take, and what the action's result. In this case, we have a mover 0. This one right here has taken the circle scan, which means it scanned from the north direction in a clockwise order and returned the 8 surrounding square of state, which are all the grasses here. And since mover 0 has just finished action, the next pulling object will be mover 1, which also get updated here. Now we see mover 1 also taking the circle scan. This is how we design our strategy, that mover will propose a circle scan whenever the surrounding square of the state is unknown to them. So in the following simulation run, looping through the mover ID 2 to 4, they all gonna propose the circle scan action. Now, since all 5 movers has finished their first round of action, the completed turn will be updated accordingly, and then the mover 0 is ready to start the second round. Now we see that mover 0 has taken the linear scan action, which means it scans from the current direction until the scan result detects fences. We design this as part of our strategy as well to let the mover do as much scan as possible at the earlier stage so that they can maximize the long knowledge. Especially it's good for them to share the knowledge later on whenever they detect each other from their scan result. However, for mover 1 and 2, you see they are making the steer action rather than the linear scan. This is also part of a strategy to let mover be smarter. Whenever they detect a gopher from their scan result, they will steer to the opposite direction of the gopher and move from there so that they can protect themselves from being chewed. Since they are making the steer action, you will see on the map the arrow has been updated accordingly to the current direction, and so does the information showing on the mover status here. And since mover 3 and 4, they did not detect any gopher, they will continue the linear scan. Now that we have a mover 0 has making a move action, which means it has made a successfully cut of the grass. So the grass of cut so far will be increased, and since it has stepped out of the charging pad, the energy level will be reduced accordingly based on the action it took. And now it's a turn for the other mover for taking actions respectively. Now that we see the next object is G0, which means it is the gopher's turn for taking the action now. So we have a gopher 0, which is this one here, move towards mover 4, and after that the coordinator is 8 and 2. So the gopher will calculate the distance from itself with all other movers and looping through find the closest one and move towards 2. In this case, mover 4 is its target. And so thus the mover 0 is the target for gopher 1. Now let's try to run with a fast forward. So the fast forward, we design an interval choices for user to choose from. The 500 has been default setting, which is a comfort reading speed. The 100 is really fast for finish the simulation run, while the 5000 offers user a slow enough to following line by line. Let's go with 500, see what's happened. So now all the mover go for well taking their actions respectively. Let's pause. So whenever user click pause, it will be held as a current simulation run. And now as here, we want to pay attention to mover 4. So whenever the mover return back to the charging pad, their energy level will be reset to full. Now let's finish the rest of the simulation. As the mover move around, whenever they crashed or being chewed, their direction and energy level will be reset to new, and so that the status will be updated to crash. So by now the simulation has finished. It will giving a message box for user. The message box here is to remind user that the current simulation has been successfully finished, and if they'd like to continue, can either choose to upload a new scenario for testing or reset the current one. User here has to manually agree with the OK button for continues. And then back to the simulation state, here the bottom 4 figures are the final report information. The first one is the size of the lung, the second one is the original number of the grafts, and the third one, which is the total number of the grafts being cutted, which also being displayed on our application, and then the complete return of the 70, which also part of our information on the interface as well. At the bottom, we will see the complete return has been raised to the 47 out of the maximum 150, and it's very obvious from the background color. If user are continue click any of the bottom, it will all give user the message to remind them that the current simulation has complete and they has to upload a new scenario for testing or reset the current one. In addition to those options, user can also choose to export the simulation result to the local. So let's choose to save it and then open. So now here we will see all the simulation state has been saved into local Excel file, and these are the same information being showing at the terminal run. And at the bottom, we will see the same figure on the final report as well. In addition to these options, user can also choose to reset. So once user hit the reset button, it set the scenario back to the original and is ready to start the new simulation run. Okay, that's all for our GUPS demonstration. I hope you will enjoy. Thank you for watching.